All right, Math 3, we're going to talk about solving polynomial equations. We have done this. This, again, is just factoring, but we're going to do a little more in-depth factoring, and we're going to talk about imaginary numbers. So we have not talked really about that. So when it asks you for real numbers include your whole, your rational, irrational, and your natural. So these are the ones that you can graph on a number line. All right, when you're going to do that. Your irrational is like pi. You would have to, kind of estimate where it would be on your number line because those numbers go on forever, but you can still graph them. All right, so we're still solving where we cross the x-axis, doing all of that stuff. It's just on the imaginary ones. I feel like we've talked about this one time. Imaginary are going to use this little letter, lowercase I in it. So if you had a problem like this, x squared is equal to -9, there is no number squared that's ever going to equal a negative. So your two, if I were to ask you to graph this equation right here, we know it's a parabola and we know it's opening up, but what's going to happen is your vertex would be above the x-axis and it opens up, which means it doesn't cross. Now, we do know that whatever your highest exponent is, how many answers you would have. So you're solving for x, you're going to have two answers here. It just happens to be two imaginary roots. Okay, so it doesn't necessarily cross because only the real ones cross, but there are still imaginary answers when you're solving. It's just they are no longer x-intercepts, if that makes sense. Okay. So you're going to come down here, you can look through that. But anyway, these are already factored for you. So you're going to do what you did on your quiz. You take your, here, put a minus here, and you set it equal to 0. Then you're going to come over here and you're going to set that equal to 0. And what you're doing, since you have an x squared and an x squared, we should have 4 answers to solving this problem. And it wants to know what are the real or imaginaries through here. So we're solving for all of them. So what you're going to do to solve for x squared, you're going to add your 1 over. So you get 1. To get rid of your square, you square root. So x is equal to plus or minus the square root of 1. Well, the square root of 1 is 1. So right here, x is equal to either a positive 1 or a negative 1. All right, so there's 2 of our 4. Now I'm going to come over here and solve. I'm going to subtract the 4 over, square root. All right, so I want plus or minus the square root of -4. Again, you cannot do a square root of a negative. That's where your I comes in. So it's a pretty simple fix. All you're going to do is take the square root of 4, which is 2. But it's going to be a 2i to let us know that negative happened to have been underneath that radical. So in this one, it's going to equal a positive 2i or a negative 2i. So here are our 4 answers. We had 2 real, and we have 2 imaginary, a total of 4 because the highest exponent was to the 4th power. All right, so if I look at this one, I'm going to have 5 answers to this one. So first I'm going to do is bring everything over and always set it equal to 0 and put it in order. So I have x to the 5th minus 5x to the 4th minus 2x. No, when I bring that over, I'm going to combine it with that. So I'm going to get a 6. 6x to the 3rd is equal to 0. All right, well, let's see if we can pull anything out. It looks to me like we can pull out an x to the 3rd. So we're left with x squared minus 5x minus 6 is equal to 0. Then we're going to say x to the 3rd. What multiplies to give us this, adds to give us that. And I believe it is 6 and -6 and positive 1. Is equal to 0. We set each of these equal to 0. So we take x to the 3rd, set it equal to 0. We take x to the -6 is equal to 0. X plus 1 is equal to 0. To get rid of a cube, you cube root. Well, the cube root of 0 is 0. So there's one answer. I'm going to add my 6 over. I'm going to add subtract my 1 over. Now, I just told you a minute ago you had 5 answers. Well, I see 1, 2, 3. Well, that's because 0 is a cube root. It has a multiplicity of 3, but these are where it's going to be on the x-axis because they're all real. It's just this one has a multiplicity of 3. So you can write it 3 times. You can put like multiplicity of 3, something like that. Or really, these are, you can just write 0, 6, and -1, knowing this has a multiplicity of 3, because we do know when that happens, it forms like a little snake along the graph. So if I were to graph that, I know I'm going to cross at 0 way down here at 6 and at -1. I know since it's to the 5th power and it's positive, I have a down, up, end behavior. So I'm going to go through my -1, but when I get to the 0, I'm going to like snake, and then I'm going to come back up through that. Okay, so I cross 3 times, but when I'm at the, if it has a multiplicity of 3, it kind of snakes through it like that. All right, let's go through and do a few more. Okay, this one, it's done a little differently. I don't remember if we've done some of these, but it is equal to 0, so that's a good thing. There are 4 terms here. So what we really do when there's 4 terms is we do a grouping method. That's explained down below, but in grouping, you group the first 2, second 2. I kind of cover up that one. I'm just focused here. I'm going to pull out a 2x squared, and I'm left with an x plus 1. Then I go put this plus sign that was in the middle, comes here, and I look at here, what can I factor out? Well, I can pull out a 5, and I'm left with, whoops, no. Don't pull out a 2. Pull out an x squared. Here I'm left with a 2. All right, here I'm pulling out a 5, and I'm left with x plus 2 is equal to 0. These have to be the same. That's why I slowed myself down there for a minute and said something was wrong. All right, you have to have what's in the parentheses the same. So I take what's on the outside, which is this, and I take what's they have in common, and I set that equal to 0. Again, I have the highest exponent is 3, so I'm going to have 3 answers here in a minute. So now I'm going to set each of these equal to 0. So x squared, I'm going to subtract my 5 and get -5, square root that. Again, when I square root, I get plus or minus negative square root of 5. Well, we can't have a negative under the radical, so it comes out as an I. And I cannot break the square root of 5 down any further. So here's 2 of my 3 answers. And then I'm going to take this parenthesis, set it equal to 0. So I have x plus 2 is equal to 0. Subtract that over, and I get -2. So here are my 3 answers. I have positive I squared of 5, negative I squared of 5, and -2. So these 2 are imaginary. So what that means is this graph really only crosses the x-axis once at -2. All right, again, we have this equal to 0. That's good. I can't pull anything out, so I got to go over here, get my target number, which is -30. Do I know anything that multiplies to give me -30, adds to give me 13? Well, 10 and 3 come to mind, but that won't give me a -30. So 6, 5, 15, there we go. So 15 and -2 multiply to give me that, and add give me that. So I'm going to write 6x over 15, 6x over -2. Divide that by 3. So I have 1 is 2x plus 5. Here I'm going to, 2 goes in there 3 times. So I get 3x minus 1. Kind of in my head, yeah, 2x, 3x, that gives me that. That's going to give me that. Okay, so now I'm going to set each of these parentheses equal to 0. When I do, I'm going to subtract the 5, divide by 2, so that gives me a -5 over 2. I'm going to add my 1, divide by 3, and I get a third. So I have 2 answers for my x to make it equal 0, and they are 2 real numbers. Oh, okay, here, it tells you all the ways that you can factor, and they give you examples of each of them over here. So, you know, you factor out your greatest common factor. You have a quadratic trinomial. Remember, like, what multiplies, give me that, get your target number, do all that stuff. These are your perfect trinomials. Remember, this is a perfect square of 5, and 5 times 5 is 25, but 5 plus 5 is 10. So those are your perfect trinomials, your difference of perfect squares. Look through those examples. Factor by grouping, that's what we did up there on number 1, where you have 4 terms. So you group the first 2, the last 2. Now, we're going to focus a little bit on the sum or difference of cubes. You're looking at cubic numbers, so you're looking at the numbers, these aren't squared, so like the number 1 is a perfect cube, 8 is a perfect cube, 27 is a perfect cube, and I think 216, that's about as big as my brain goes. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, 5, 5, 5, 6, 6, 6, okay. These are your perfect cubes. If you recognize those, then you're going to follow this pattern. All right, so when we get to that, I will show you how to do it. They talk a little bit on page 267 about it up there as well, and they give you some examples of why it works. And down here, again, we have some examples. You can kind of look through them. All right, so here again, we are solving by factoring. So what are the real and imaginary ones of each of these polynomials? Again, set it equal to, well, this one, I guess you don't have to set it equal to 0 because it's just going to bring it back over, but yeah, I'm going to. Bring the 16 over, set it equal. This is kind of your difference of perfect squares, so I'm going to do x squared minus 4, x squared plus 4 is equal to 0. Now I'm back to a difference of perfect square on this one, so I get minus 4, or 2, sorry, 2x plus 2. This one does not have a minus in it, so I cannot factor that down any further. Now I'm going to set each of these equal to 0. So if I set this one equal to 0, I get a positive 2. Set this equal to 0, I get a negative 2. Now, when I set this one equal to 0, I subtract over the 4. Again, square rooting. We just did this a moment ago. You're going to get plus or minus the square root of negative 4, which again is plus or minus 2i. So I get negative 2i and a positive 2i. These are my 4 answers. It was to the 4th power. I need 4 answers. 2 real, 2 imaginary. I cross the x-axis here. These I do not. All right, over here, again, setting equal to 0. You're going to add that 2x squared over, subtract the 8x, set it equal to 0. Common factor is an x. So I pull an x out of everything. And then we say to ourselves, what multiplies to give me that, adds to give me that. Let's see, 4 and 2, this is not gonna, yeah, it will work. Okay, so x plus 4x minus 2, set it equal to 0. Now I'm gonna set each of these x's equal to 0. When I do that one, I just get a 0. When I do this one, I get negative 4. When I do this one, I get a positive 2. So there are my 3, and those are all real answers, so I will cross the axis 3 times. Okay, on here, you're going to have to distribute this across. So you're going to get x to the 3rd plus 8x. Over here, you're going to get 8x plus 8. Get everything over to one side. Well, if I subtract the 8x from the 8x, I don't get anything. And I need to subtract this 8 over. All right, so here's our first perfect cubed, okay? Again, these canceled out because I subtracted them over and then I subtracted the 8 over. With your perfect cubes, you can have a plus or a minus here. On your perfect squares, you have to have a minus. All right, but on perfect cubes, you can do either one. So here's how you do this. Your first parenthesis is what is the cube root of x cubed? Well, that's x. What is the cube root of 8? Well, that was 2. Then what I want you to do for the next one is you're going to use a pattern. Don't even look up here anymore. You're just looking at these two numbers. So you square the first one. So x squared, change the sign. If that was a plus, you write a minus, etc. So then you multiply these two things together. So 2 times x is 2x. This one is always a plus sign, and you square the last number. So once you write this, then this goes square, multiply, square. Square, multiply, square. And that's what I put here. So square, multiply, square, and that's what goes here. Then I'm going to set each of these equal to 0, and I set this parenthesis equal. I get x to equal 2. This one I start thinking, is there 2 things that multiply to give me this, add to give me this? There isn't, so I have to go to my quadratic formula. All right, quadratic formula is the opposite of b, plus or minus b squared minus 4 times a times c, all over 2 times a. So I'm going to get negative 2 plus or minus. Here I'm going to get 4 minus 16, which is negative 12 over 2. All right, here comes some fun math. Here we go. The negative comes out as an I. Square root of 12, if you remember, is the square root of 4 times the square root of 3. All right, so we have negative 2 from here. The square root of 4 is a 2, so it comes out front. The negative comes out as an I. I'm left with the square root of 3 from that 12 all over 2. All right, so the square root of 12 is just 2i square root of 3. Now, if you notice, all of these have 2, so I can divide this by 2, this by 2, and this by 2. So this becomes a 1, this becomes a 1, that becomes a 1. Now, this one and this one really don't matter. I don't need them, but I do need this one. So, finished answer. So, we already found one was -2. The other answer is going to be -1 plus or minus I square root of 3. So, -1 plus or minus, I square root of 3. And those are my 3 answers that came from here because it was a cubic. All right, so 2 came from right here, did the quadratic formula, a whole lot of fun simplifying going on here, and this is what it simplified to. And there's your finished answer. All right, so here we go again with the real and imaginary. So I'm going to subtract the 1 over. I noticed perfect cube. So 2x would get me to here. 1 would be the perfect cube of this one. Remember our pattern. Square the first term. Change the sign. Multiply the 2 terms together. Always a plus here, and then you square 1. All right, again, since it's cubic, I should have 3 answers. So this answer I'm going to set equal. I'm going to get x to equal 1/2. Then I have to go and do the quadratic formula to this one. So the opposite of b plus or minus b squared minus 4 times a times c all over 2 times a. All right, now it's just a matter of simplifying that down. So -2 plus or minus, in here it looks like I'm going to get that 4 minus 16 again. Okay, so -12 all over 8. Remember, -12 was 2i square root of 3 over 8. All of these can be divisible by 2. So joining my 1/2 over here, if I divide by 2, I get -1 plus or minus I square root of 3. 8 divided by 2 is 4. So the finished answers would be these 3. And again, this one I can't graph because of the I in here. This one I can. Okay, here's just find the real roots by graphing. They probably just want you to do it by a graphing calculator, and wherever it crosses the x-axis are your real roots. So we're not going to worry about that. Okay, that's probably about it. If you have any questions, please just get on to like YouTube or something like that and see if they can show you other ways. But I will put your assignment on Google Classroom, and let me know if you have any questions.